Hey, Jack.
Hi, everybody.
How's
Hi,
Is
Brady.
Hey.
How many of you are not on a laptop or a computer?
So I just switched over to a computer today, but I don't have a camera, so that'll be the only downfall of that.
That's okay. I just want to know how many of you can write logic using the screen control.
I'll be able to in about like 20, 25 minutes. I'm in the car right now, so I'm on my phone, but I'm going to be switching over.
Okay. Let me rephrase. Does anybody not have access to a computer and a mouse for these sessions? Hello?
I do not have one, Zach, with me at work. I could bring one with me.
But at some point you could, like for a final exam.
I could bring a laptop. Well, on a final exam, I'll probably stay at home to go over that with you. But for classes like this, I could bring a laptop with me if I needed to.
No. I just want to make sure everybody's got. I mean, I'd like it if during class we could all take turns doing the screen control thing. So, but I mean, I understand you got to work. So, all right. Well, I guess we'll get started.
God, Jacob, why do you have to support yourself?
I don't know. It's kind of a pain.
Yeah. What kind of adult are you?
A lot of this stuff, Zach, I feel like I already kind of went through. So I'd rather let someone else kind of do it so they can get practice with it.
That's the attitude to have. Somebody else will do it.
That'd be awesome.
Yeah, starting next Monday, I'll be back at work, so I won't be able to during the sessions either. I forgot about that. Because I'll be calling in on my lunch break.
Okay. All right. Does anybody remember where we left off?
We were talking about the glue gun.
Thermocouple?
That's the wrong class, Jay. We're talking PLCs today.
Oh, that's fun.
And please hang out. The more the merrier. Jay?
Yeah, you guys are working on that process for the water heater and the muffin fan and all that.
Yep.
I remember, right?
Yep.
And
I believe we had
quite a bit of confusion at the end.
No.
Oh.
The exhaust fan, we did the math and got that running at, what did we do, 80%?
65 maybe? 65 or 80.
65 is what it was.
Remember which.
I didn't do 80, I think. Now we have to do the temperature control. Right?
Yeah, no, we were doing the temperature control. I thought the reason we were having discourse is because it just said it had to come on, and you wanted it to be 50% because you didn't want it just going full power and the table shaking. Is
Oh,
that
we did 50%?
yeah, no, we did yeah. No, we did 80%. I think you're right. Because you wanted it going pretty fast. Let me just log in real quick and make sure what I'm saying is correct. To Discord. I mean, not Discord.
Can everybody
What?
see me okay? I got it downloaded to where we were at the other day. Remember, I started putting stuff in there, but I deleted it. So we are where we left off as a class. But this is where we're at. Left selector switch, the top green turns on. And then start button. Start button does nothing. Well, that's a problem. Let's try to figure out why.
Oh, I wish I had a.
Why is the proc switch reading on? We've lost the proc switch. Hang on. Okay, we got the proc switch back. Don't worry, it's all okay. We're all good. Can you hear me? Hello?
Yeah, we can hear you.
Okay,
What was the problem?
just a loose connection. What am I sharing? Am I sharing anything?
Nope.
You're showing you right now.
Your beautiful green eyes.
Hello. All right, what are we doing?
So the part I remember being at is the temp control, and we were trying to decide at what point the heater should turn on and what point the cooling fan should turn on and how to integrate that with the thermocouple.
Right. So at this point, now that I have that fixed, pressing the green button puts that as the exhaust fan at however much percent that is, and flashes the green pilot light. So that would be selector switch left, off, green flash, blah, blah, blah. Exhaust fan turns on at 65%, stays on. And now we're at this part, temp control. So we need to use the heater and the thermocouple and the cooling fan to keep the temperature between 80 and 120 degrees Fahrenheit. I'm going to change that, by the way.
Why? Why?
Well, I guess we can.
No, I'd understand if you wanted to change it, especially since 120 seems like a high degrees to even see.
No, it's not that. It's more, it's okay because the digital display, we're going to display that in Celsius. Because that 3-digit digital display only goes up to the number 100. It goes 0 to 100. Does that make sense?
Yeah.
All right, so whenever the heater is on, the bottom red pilot light flashes at a rate of 0.2 seconds. Ooh, that's fancy. And whenever the cooling fan is on, the strobe light is also on. Okay. Who wants to go first? Nathan, I think you're up.
Hang
Hang on a second.
Oh, there we go.
Hang on.
I'm not doing anything.
Hold on.
Okay.
Hold on. Turn this bad boy off, and I will give you. How do I do this? Remote control. All right, you're up, Slugger. I want everybody's mics on and participating and having fun.
Okie dokie. We can do that.
Oh my gosh.
Hang on a second, Nathan. Give me the mouse. Can you guys see this thing over here? This whole long schmear?
Yeah.
Oh, okay. We got to get that out of the way. There we go. There we go. There we go. All right, you can have it back, Nathan.
Thanks.
Oh, you're welcome.
Where do I go?
You got this, Nathan.
So what are you thinking about doing, everybody?
Sorry, my father walked in and was talking to me. I'm thinking Luke will know what to do. Luke, tell us what to do.
I'm gonna pass it off to Kenzie.
Should we do a compute function for the thermocouple?
Compute.
Yeah. Do you remember how I started to approach it the other day?
Yeah, Brady, I thought you had this written down.
Am I supposed to?
No, someone had it written down. I think it was either John or you.
I have.
Wait, the math we did?
I know how to do
Friday?
a compute function. I think
Yes.
the range. I have the range written down as 6,241 to 31,206. Destination would be the
I think I have
thermocouple.
that. I'm not sure. And I'm not sure about anything, but that's whatever.
What is the thermocouple? Anyone? How do I,
Is it the temp sensor? Or does it actually say
no, it'll be the temp sensor.
temp heater?
Nope, not the temp heater. The temp,
That's all right.
yeah.
So that's module 7, channel 3.
There it is.
Do I just double click it?
Yeah.
All right, what do we want to do with this?
Well, put in the expression for 80 degrees.
So that would be the math we did yesterday. Or not yesterday, Friday. Degree would be 26.67, no, 26.62 or 67.
Oh, what do we need it to,
Jesus, stop screaming.
Let me ask you a question. Why are you making the destination for this formula the input of the temperature?
I don't know.
You might want to use the input of the temperature in your formula, right? But what are we trying to accomplish with this wrong? Let's start there.
So what I'm trying to do is interpolate it so that the it can read as temperature and not the numbers it processes already.
Well, that has to be the expression though, but the destination, what you're moving that equation to, is thermocouple. So you have to split.
I mean, I guess I could put it just as a bit for now afloat.
That's a good idea. So let me get this straight. And just so everybody's on the same page, we're going to use this rung to take the input of the thermocouple coming from that puck, a 4 to 20 milliamp signal. And we're going to convert that to degrees Celsius.
No, we're going to convert it to Fahrenheit, right?
We can.
Well, because if we, I mean, I guess we could convert it to Celsius, but it needs to be in Celsius is only used in the display. Fahrenheit is used for the both the fan and the soldering iron.
Okay. Well, let's use this rung to just show us what the temperature is in Celsius, and we can assign that number to an F8, to a float. Should we do that?
Yeah. So that's what I got it as an F8, and so the way I'm thinking, we need to interpolate
Or 2 degrees. Like, so if it's between 80 and 120.
Well, what are we going to see in that input 7? What is it? 7.3. What are we going to see? What's the PLC going to show us?
it's gonna
41 to 31206.
yes.
Okay. So we need to turn those numbers into degrees Celsius, right?
Correct.
Okay. Well, let's do it.
Someone give me an expression. I don't have the interpolation expression up in my head. And we need to do it not from 80 to 120. We need to do it from 0 to 120.
0 to 100.
0 to 100, yep.
So that puck that thermocouple is connected to is rated to give you an output of 0 to 100 degrees Celsius.
So your two numbers are the 6, 1, yada, 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 to the 3, the 32, yada, yada, yada. And high on the other one is 0, low on the other one. I mean, high on the other one's 100, low on the other one is 0.
Mm-hmm.
And then our not our constant, but our the opposite of a constant is the number the thermocouple is showing.
Correct.
So I need a formula. Someone, anyone?
Come on, people.
What? I have to repeat that. I didn't understand a thing.
Let me have it for a second, Nathan, okay?
Okay, and I'll start looking it up.
Nathan, what are you looking up?
I'm looking up the formula for interpolation and inputting the.
Well, first, when we just get our 2 degrees that we want in between into Celsius, since it's 0 to 100.
No, you don't want any numbers in between because the thermocouple will show a number from 0 to 100. So we need to input those numbers in. To formula. Let me get a pencil. Give me a second.
Anthony just gave us a formula in the chat.
Yeah, and that's I have that written down. I don't remember what it's for.
Interpolation.
Interpolation for what?
Everything. Interpolation is just.
Are you looking at what you put?
I'm looking right now.
When it's a number.
That would be interpolation for the temp system.
All right. So we're trying to interpolate from 6241 to 31208, right?
Correct.
And that's going to be 0 to 100, right?
Correct. And our floating will be, and then our in between will be the floating number and the temp sense number.
All right. So that's going to be input 73, right?
Mm-hmm.
It's going to be some number between. It's going to be some number between these two. That's what our temperature reading is.
Correct.
So input 73 minus the bottom number, right?
Correct.
Then what?
Times.
It wouldn't be the percentage.
Trying to find a percentage for this number.
You can't.
Wouldn't it be based on the 2 temperatures we want it between?
Yeah.
So is that still 80 to 120 degrees?
No, right now we're just trying to figure out what the temperature is in degrees Celsius. That's it.
What temperatures? Like right now?
Yeah.
So the formula for Fahrenheit to Celsius? Or is it reading? What is it reading right now? Is it reading Celsius?
It's reading a digital number, so it's not reading Fahrenheit or Celsius. That's what we're trying to interpolate into, is so that it reads Celsius.
Right now we have a number that's 9582.
So we have the number minus the number times the highest digit.
Zach, if I remember right, we need to divide that top expression by 31,207 minus 6,241. And that should give us a percentage.
Okay.
Times. So wouldn't it be times 100 minus 0? So just 100?
So input 7.3 is going to be somewhere in between these two numbers, right?
Okay.
You want to take that and make it a percentage. Take that and apply it to a range of 0 to 100. Right?
Right.
So we want to take input 7.3 and subtract the lower number because we want to find a percentage of this range. So I7.3 minus 62.41.
So the formula I got was I73 minus 62.41 times 100, all of it times 100, divided by 24,967 will give you Y2.
Yeah, but you should divide the whole thing by the 100 minus 0, correct? So it'd be
No, I divided the whole thing by the
right.
31208.
We want to interpolate this into the same range, so it would be 31,208 minus 62.41 first, and
Yeah.
then we would do it into 100 to 0.
The formula I'm looking up online says that it's x2 minus x1 times x3 minus x1 divided by x3 minus x1 plus y1.
That's if
That's
you
interpolation.
want to know. Okay, yeah, and that works.
Wouldn't that be our last edits number though? Since we're trying to find the percentage right now.
What I have here will give you a percentage of this range, right?
Yeah.
Yeah.
So no matter what number we plug in here,
It'll be a percentage of the range.
everything in this bracket will give you a percentage of that range.
Well, it's not going to give you a percentage yet, though, Zach, unless we multiply it by 100. That's going to give us a decimal.
Right, but we need to use that decimal. So yeah, if you
To
want
interpolate the 0 to 100.
right, but if you
Yeah.
want the whole formula, we take this times times this range, which is just 100 minus 0, correct?
Yeah. Yes.
So if we take this times 100, that will give us degrees Celsius, right?
Right. So
If
the
we're
easiest
making it an expression in
Forest logics.
Yeah. What is our formula going to be?
So parenthesis,
Wouldn't it? Go ahead, Brady.
parenthesis, I7, I7-3 minus 6241. Parenthesis. What would be? Is there a division sign? Would it be a? Yeah, divided
There you
by
go.
parenthesis 31208 minus 6241. Parenthesis, right? And then times 100.
That look right to everybody?
Yes.
Yeah.
All right. I'm going to copy this in there, but this, if we put I7-3 in there, it's not going to know what to do.
Okay. What would we put in there instead then?
I use that drop down menu.
Yeah, drop.
So wouldn't it
Put
be
that bit in
the
there.
number that it's currently reading?
Yeah. So here's what, okay. So here, I'll paste this in here and then I'll let you do it, Nathan. I'm just going to delete this and then I'm going to give it to you.
Okay. Oh, dude, Sour Patch Kids.
So there, over there on the right-hand side of that formula box, there's a couple icons. The top one will give you a drop down for your tags.
Oh, dang it.
Just go double click on that expression.
No. I was out of full screen for a second. Okay.
Okay, now put your cursor right before where it says minus 6241.
Now what?
Now go to the top icon on the right. Looks like a little tag. There
One
you
of
go.
these?
Yep. See, it says browse tags.
Okay, now I see it. I thought that was a pencil.
7, and then we want
3, right?
channel 3 data, temp sensor. That's it. So if you download and run this, that F81 will become the degrees Celsius. Let's go ahead and download and run it. Oh, never mind. We're in run mode. So go, you know how to accept the edits?
I do not.
Underneath where it says compute math. Right here.
I can't see what you're pointing at. Oh,
Nope. Let me show you. Right here. This is compute math. This will let you accept the edits if you make edits while your program is running.
Oh, right under it. Okay, so right.
Nope, to the right. To the right. To the right. To the right. Yep.
There we go.
Yep.
Right.
Yep. Say yes.
Yeah.
Cool. Now it's giving us 13.4 degrees Celsius.
That does not seem right. Oh, yeah, it does. Never mind.
So let's have another run where we convert that to Fahrenheit, just using math, and we'll assign it to F8 too.
God dang it.
All you gotta do is times 1.8 plus 32.
Yeah, is that we have to put that in a function though?
Yeah, so we'll
So that will that bit be the destination? Because we'll want that number constantly, right?
yeah, it'll be like a live.
Right.
What is that question mark before it?
It just comes up by default. Just delete it.
Okay. John, one more time because I'm not the smartest.
It's
Go ahead.
yeah, times 1.8 plus 32.
Any parentheses? Or is that it?
You shouldn't have to.
You shouldn't have to because it will follow order of operations.
Fair. All right, that look great, guys?
Yeah.
Looks good to me, brother.
That
All
looks good.
right. Before we go anywhere else, I think our best option right now is to how would we take that F8 and put it on the digital display?
Well, wait, shouldn't our rung 9 compute function be showing a number right now, but just in Fahrenheit instead?
It
Well,
should.
it
He hasn't
He hasn't
added the edit.
And you have a blank run, so it won't work right now. So you want
Yeah. Input output. There we go. Nope, that's not the right one. There we go. Oh, that's not the right thing. Anyone want to tell me how to put that F8 on a digital display? Oh, we use a move function, would we not?
Yeah. But this becomes a little difficult. Do you want to know why?
Why?
That digital display.
Oh, because it's reversed. Dang it.
Inverted.
I'll walk you through that part. Do you want to do that part next before we start controlling the temperature? That's fine. We can do that.
All right, so what do I need to do?
So instead of 100, would it be 0? Is that how we would invert it
Yeah, but you have to put a
in our
form.
function?
It's really not that difficult. It just
Sucks.
it's kind of a pain. What would you like to do now?
Uninstall the current digital display and put a new one. No, let's go ahead and do the I'm gonna real quick delete this wrong. Then I am going to accept this logic. Oh gosh. There we go. Is it really 50? That's not right. That does not look right.
Pretty chilly in here.
Is it 56 in your garage?
It's more like
He's in
60.
his garage.
Okay. Well then, that's right. So what do you guys want to do? Come on, give me suggestions. John?
Let's tackle outputting that display.
Okay, I can do that.
What do we need? We need a move, right?
Yeah. Do I just? Yeah, sure, cool.
So what are we gonna move?
The
You know what the destination is, right?
the number of our compute function, since is that 0 to 100 in Fahrenheit? Is that what that sensor reads out, or would that be a percentage?
No, we're doing the Celsius one, not the Fahrenheit one. So we're gonna do the F8 one. Right?
No, you do F83 because that's the Fahrenheit. You want it in Fahrenheit, don't you?
No, you want the read this.
Don't we want it in a percentage though?
Yeah, but that's okay because it's 0 to 100.
So we'd use the
Right.
Celsius.
Yeah, if you look on the Blackboard side, it says do it in Celsius, that digital display.
Then
Oh.
why'd we even worry about Fahrenheit?
Because in Fahrenheit, we're going to need to get it's for Fahrenheit in the way the temperature actual changing works. The fan goes on at 120 and the heater goes on at 80 degrees Fahrenheit.
Oh, okay.
So F81. But how would we invert that source?
Let me ask you this.
Take the whole thing over one.
Really? Would that work?
No. Let me have it for a second, Nathan.
Yeah, go ahead.
Right now we have 13 degrees Celsius. If we wanted, if we didn't have to invert this, if our digital display output was 0 to 5 volts, and what are our numbers that we need to output?
Is it the 61204?
It's actually 0 to 31206.
Okay.
Right.
So if we wanted to come up with a number and output it somewhere in here using this number, what would we do? We would just take a percentage of this range, right?
Yes.
And move it to that destination. So it would just
Right.
0.134 times 31206. Does that make sense to everybody? This is degrees
Yes.
Celsius, but it's also a percentage because it happens to be 0 to 100. Making sense?
Yeah.
Oh.
Yes.
So if I took 13.4 or 0.134 times 31206, I'd get 4181.6, and if I put that in there, then that display should output the voltage that would make the number 13 show up, but it's inverted. So instead of using 13.4%, what would the opposite of that be?
Not negative, would it?
No,
I mean, the
it'd
opposite of a number would be negative.
be 100 minus 13.
It would be whatever makes this, whatever you would have to add to this to get 100.
Right.
86.6.
Yeah.
It'd be 86.6. Is that what you said, Brad?
Yep.
Yep, perfect. And isn't that the same as saying 100 minus this number?
Yeah.
Mm-hmm.
I mean, that's what it did.
So that's what we would need to use in our formula. To simplify it, I would take what do we have? This 13.42 and divide it by 100 first to make it 0.134. So then I'm just going to say 1. No, we don't have to do that, do we? Yeah, we do. I would change this to a decimal first instead of the percentage. So I would say 1 minus, what is it? I guess it doesn't matter how we do it. What would our formula be? If this is, this just happens to be, what is that? F8, what is it?
F81. So would it just be 100 minus F81?
Yeah. So 100 minus F81.
Would this be another compute function or a move
Yeah,
function?
we're just going to compute it first.
Yeah.
So 100 minus F81, and that will give you the inverted percentage. We need to take that divided by 100, correct? Before we multiply it.
Correct.
Yes.
Times 31206. Correct?
Yeah.
Yeah, sorry. I'm writing stuff down.
I am glad you're speaking while you're writing because holy smokes, I cannot understand what you're writing there.
That's the most beautiful handwriting ever.
Like I almost want to buy you one of them Google Pad things where you can just actually write with a pen on there, so I can understand what you're writing.
I really should get one, but
the school ought to get you one.
Yeah. Yeah.
Yeah, they should. Now, FA1, so that's going to spit out a Celsius on our display. Don't we want to use F83? That's our Fahrenheit number, right?
No, because we don't have to, we're not putting Fahrenheit on the display. We're putting Celsius on the display.
Oh.
What we're told we want to do is keep it between 80 and 100. So all we need to do is figure out what 80 Fahrenheit and 120 Fahrenheit is in Celsius and use those numbers.
Well, I mean, if we're going to keep it between 80 and 100, you know, I don't know the conversion off the top of my head. So would it make more sense if we're going to work in Fahrenheit to display it in Fahrenheit?
Yes, but that becomes extremely difficult with this inverted 0 to 5 volt display.
Okay.
I have the logic to do that, but that's another day. Like if we get time, I'll walk you through that math. It's just kind of ridiculous.
Okay. It's that hard to do that?
It is because you're taking 0 to 100, inverting it, and converting
and then
it,
interpolating it into Fahrenheit,
and putting that back on the. It's different ranges, different. It's a little. I've actually been working on it for a few days and just now got it dialed in this morning. So.
Anybody want to give me the digital output, display output real quick?
Yeah, hold on, Nathan.
Module 5, channel 0, I think.
That's correct. That's what I got.
All right, let's check this work real quick. Zach, can we see your screen, please?
We are.
I can't see it.
You need to pin him. Click on his photo and pin it.
Well, that's not right.
Yep, it's reading 100.
I lost your screen.
Could I get control again real quick, Zach? Okay, so what we're going to do, if that would get out of the way, is I'm going to...
You didn't add the multiplication from the formula that you wrote out for the CPT. Do we not need it?
We have a bunch of CPTs. Which one are you talking about?
Yeah, see in that one that you're highlighted there, 100 minus F81, you guys didn't multiply it by 31,206.
Correct.
Do we not need to do that?
You need to.
It's not.
So in 110, all you're doing with that formula is inverting the percentage. So this makes sense. Okay, so you got if this is 13%, then this should be the opposite, which is 86%. If you add those two up, you get 100. So this is perfect. What we have to do before we move it to that output is convert it to that 0 to 31,206 range. So remember what we need to do there? John was right.
multiply the number. So like the 13, the
So take that
0.13.
whole formula and multiply it times 31206. And if you're going to do that while we're in run mode, you have to double click on the rung number. There you go.
Ooh. Ooh. So
You put it at the
Yeah,
very
Just
front.
like put the entire thing in parentheses and then times 31206.
okay.
Make sure I said that right.
Yep. You're right, Brad.
No, Brad, you're not right.
I know, John. I'm usually not.
No, you are, buddy. Giving you shit.
I know.
So when it comes to how woodchuck and chuck wood.
And if we did that right, what should the display read?
Oh, whatever it is in your garage in Celsius.
Yep.
Yeah.
Should read
Is
13.
13 degrees.
And it's not.
What's it reading?
Reading 0.
Yeah.
Let's double check our IO.
Wait, did you
Wouldn't you multiply it by the bottom number, not the top?
wait, it's excluding that rung now.
Oh,
Don't you have to like
Wait a minute.
accept edits or something?
I already did that. That's why I just double clicked it again.
Oh, okay.
Oh,
Would it be the bottom number? You want to try the bottom number real quick?
Hey, that's supposed to be 31206, isn't it? Or is it
Yeah, it's 31206, not 32.
That does make a difference.
All right, let's try this. What's it say now, gentlemen?
0.
Mm.
Hang on. Before we go on, I want to make sure the IO is configured correctly. So let me. What is that? Yeah, 5. That's why.
It's 0 to 5. What is it? 0 to 5?
0 to 5 raw proportional. So percent range is that's something I changed the other day. You can actually make the data format come out to a percentage, so you can skip those steps, but it'll come out to like, anyway, I'm just going to fix it so I don't confuse you. I think we're good and we're right. It's just the configuration needs to change.
Why do you hate me, Kenzie?
Oh, your leg. Oh my god. I thought that was just.
Don't make a mess, Tierney. And don't be adding anything without asking.
What's it read? I can't see.
I can't either.
Oh, that works.
At 15. It's pretty close.
Pretty close.
Good enough for what we're doing.
Why not seeing?
Can you read it?
Oh, there we go. Yeah.
Cool. So what do we need to do? Tomorrow?
Yeah. Tomorrow we will get the ranges in.
Well, tomorrow I think we're working in our groups to do trainers.
No, that's right.
I thought we were doing it separate times.
We'll pick this up on Friday.
Friday.
What about Wednesday?
So my group is
PLC's on
Thursday.
Robot, yeah. It says that the pilot light needs to flash for 2 seconds when the soldering iron's on.
We're not there yet.
Right, that would be next though.
Oh, okay.
Mm-hmm.
Yep. Right. So right now, all we got is we're displaying the temperature. Cool.
Cool.
Yeah.
Cool.
So when does Group 4 meet up?
It says it on the
Wednesday,
website.
10:30.
At 1:30 on Thursday?
10:30. 10:30
30?
Thursday.
It is on.
So I'm not meeting up. So we're not all meeting up tomorrow and Wednesday?
No, you have tomorrow off, Don.
And Wednesday?
Wednesday we have class. It's just like our regular schedule that we had before all this.
So
Like,
Mondays, Wednesdays, Thursdays, and Fridays.
yes, now it is, yeah.
Mondays, Wednesdays, Thursdays, Fridays.
And Tuesday, right?
It is on Blackboard.
Well, you guys just told me that we're not meeting tomorrow.
And it
Not
is
everyone's
also
meeting.
all right. Don, can you hear me?
Yeah, I hear you.
It's on Blackboard and it's also on the shared drive, the shared Google Drive. So if you go into this drive that everybody can see now and you go to the plan, Tuesdays and Thursdays is Tuesdays, who's group 1? So Mark, Brayton, Anthony, Aaron, we will talk tomorrow at 9:30, and then Brad, Jacob, and John, we will talk tomorrow at 10:30. Right?
Right.
Yeah, I got it.
Wednesday will be the robotics CNC class. Thursday will be groups 3 and 4. And Friday we'll pick back up on this trainer exercise. Cool?
Cool.
Okay.
All right.
For me.
Y'all have a good day.
You
Yeah,
too.
you too.
So, Kenzie,
What, Nathan?